So we're supposed to figure out the antiderivative of 5 to the x power. So that's the computer notation for it. It looks like this. And they gave us a list of options. We don't actually have to calculate it ourselves. They said here's an option, here's an option, here's an option, and here's an option. So to figure out which one of these is the correct antiderivative, we just need to take a derivative of each of these with respect to x, and whichever one equals 5x is the correct one. So let's take this first option. So 5 to the x power times natural log 5. And you might think this rings a bell, but this is actually what the derivative of 5 to the x would be. Okay, so if you take a derivative of this with respect to x, the derivative of, actually first let's say this, the natural log 5 is a constant, right? So that doesn't impact our derivative. We don't have to use the product rule or anything like that. But the derivative of 5 to the x is itself, and then we need to multiply it by a natural log of the base. Anytime you take a derivative of an exponential function, the derivative is itself times a natural log of whatever that number is that's being raised to a power, 5 in this case. We call that the base. Now that's the derivative of 5 to the x. We also have another natural log 5 happening. And then the derivative of c, which is just a constant, with respect to x is 0. So this is the derivative of this term up here. So this is not, we haven't found the antiderivative because it's 5 to the x times natural log 5 squared. So that one's out. The next one on that list, it's 5 to the x over natural log 5, and this sounds promising because that will make that natural log 5 that comes out of there cancel out. Remember, this is dividing by natural log 5, so it's the same thing as multiplying by 1 over natural log 5. So when we take a derivative, we just need to worry about the terms that have x involved. The constants just stay multiplying at the end. So the derivative of 5 to the x is itself, here, separate this, I'm taking a derivative. It's itself times the natural log of the base, and then we divide by natural log 5, because that's what it said to do over here. That's not part of the derivative. We took a derivative of 5 to the x. It's 5 to the x times natural log 5. And these two terms cancel each other out. Oops, sorry, and this is gone too, because when you take a derivative of a plain old constant with respect to x, it's 0, right? Because it's not changing with respect to x. And so this is our antiderivative, this one right here, because when we took a derivative, it turned back into 5 to the x.